Hey everyone, we're just going to go over in this video the basics of sets and counting. A set is a well-defined collection of distinct objects. The objects of a set are called elements. So you can have a set of books, and each book is individual and distinct, and they would be called the objects. The well-defined part means that there's a rule that enables us to determine whether the given object is an element of the set. So the book belongs to the set of books. If a set has no elements, it's called the empty set or the null set. Okay, and you're used to seeing it like that. Okay, there's ways to write elements of a set. For example, so for sets, you don't write it double. So I don't write like 1, 2, 3. That's a set of numbers. I don't write 1, 2, 3 and then write 2 because that wouldn't be distinct. The 2's are the same, so I would take that out. The order doesn't matter. So actually for this set, I could write this as 3, 2, 1 or mix it up even further. Okay? The next thing we're going to talk about is the subsets. We can have two sets equaling each other. So we can have a set A equals set B. We can also have a set A as a subset of B. Like for here, we could have it could equal or be a subset of B. Or we could have A as a proper subset of B. Okay, that means that A can't equal B. And there's an empty set or null set is a proper subset or a subset of every set for any set A. Okay, now let's look at what we have, some examples. We have a universal set here, and we have set A, and we're going to talk about the complement of A. So write it like this. Some people write it with a tilde sign in front. We're going to use the bar A. So the complement of A is what's not in A as compared to the universal set. So we look at this and what is not in A that is in the universal set, and that would be our even numbers here. Okay, so what I want to do now is talk about the intersection of sets. So the intersection of sets is denoted as A intersection with B. And if we have A intersection with B, intersection means the set consisting of elements that belong to both A and B. So are there any numbers that belong to both A and B? And there's not. So that's why it's the empty set. That's why you need the empty set. Because you have to have, that's kind of like the zero of the set. There isn't anything. All right. The union of the set, and it looks like, I call this the U. It means the set consisting of elements that belong to either A or B or both. So A or is the key word, or B or both. All right, this is the intersection is more like and, what's in both of them. And this is more like or. Okay, so A union B equals the universal set because we're picking the numbers that are in A or B, and that is all of the numbers here. Okay? Let's do write out the elements of the set, and right here, a set, if A is a set within elements, then A has 2 to the n elements. So what this means is I'm going to write all the possible subsets of this set A. So the first thing I'm going to do is I already know that the empty set is a subset. And you don't write it like that because it's already called empty set. So you don't want to say set, the empty set of the set. And then the other sets would be A stands alone, B stands alone, C stands alone. Then we could put A, B, C together, as we already have, which would be kind of the universal set. Then we can mix A with B, and then we could have A with C. Then we could have B with C. And I'm going to put this in red. So when we count this, we have 1, 2, 3, 4, 5, 6, 7, 8. All right? So basically, the number in my set here is 3. So I have a total of 2 to the third power elements. And that's going to be 8. Okay? So that is, well, it's not actually elements, it's subsets. Sorry about that. All right? So these are all the 8 subsets of my one set. Now, this is a typical Venn diagram that we use for sets a lot, and you have probably seen this before. The intersection of A, B, and C, so that would be, the intersection means the sets that are in, that belong to all of them would be this part right in here. All right? So that would be the intersection there. So we're going to use the Venn diagrams in other videos. Now, here's some other Venn diagrams that you might get used to. So this is what a Venn diagram would be for A to be a proper subset of B. So this is a proper subset. This would be like a group of students in a class that's separated out from the class, but they're in the class. This group is doing something different. All right? Then we could have A intersecting with B, which is the empty set. That means there's no elements in comma here, in comma. So there's A and here's B, but there's no intersection. Okay? This would be the disjoint, okay? So that's disjointed. When you do this and you have the intersection, this is the intersection. The intersection would be right in here. For the union would be all of it, because the union is A or B, or both. So that would be the whole set here. And then we just got through talking about the complement. The complement are all the items that are in the universal set, but that are not in the original. So this is called the complement of A. Okay? The next video we're going to do is specific problems and go over 3 theorems that are basic to sets and counting. Thanks and have a nice day.